I was looking at this question at an event last week, and we were thinking about how do we, first of all, get all children accessing this task? And then how do we really draw out the reasoning to take children beyond a trial and error method and get them developing a strategy? The key idea with this question that we want to work towards is that those two numbers add up to make the red box, and those two numbers add up to make the blue box. So that value in the middle, well, to make the 50 is comprised of the 18 plus the 12, which of course is 30, plus that middle value, which is added twice. So rather than it being 20, it is in fact 10. And this shows the question, the solution to this question. So let's work backwards from wanting children to be able to see and do that. First of all, we might give children essentially the whole and two-part structure and show them those two examples. And then can they identify which is the correct value for each box, and can they explain this? And that might lead into this stepping stone task, where essentially you can work out each value by using that part-whole understanding. And having worked through those tasks, we might then progress to here. Have a look at these two images and ask the children to spot the difference. And then the numbers at the top will be the same. Do we agree or disagree with that? Then we can work them through. And often to children's surprise, what we come to see is the values in the top boxes are different. Can we explain why? And that might lead into this next step. Agree or disagree? The number at the top is the sum of the three numbers at the bottom. Now, a task that I like to go in with next is to give children 20, 12, and 8, where of course 12 and 8, the sum of 12 and 8 is 20. And it's to children's surprise often when they figure that the number in that bottom box is actually, must therefore be a 0. But then that leads into this minimally different question. And I ask the children to spot the difference. And we notice we've still got the 12, the 8, and now it's not 20, but it's 22, it's 2 more. And so the number in that middle box at the bottom, is it 1 or is it 2? And again, children instinctively might think it's 2, because 22 is 2 more than 20. What, of course, we come to see is that value we add twice, so it's actually 1. And then again, show the number sentences to demonstrate how that top number is constructed. Now, that might lead into this task, or a task like that, where you use numbers in a different number range. Children can move on then to creating their own examples. And again, if I wanted to extend the challenge, well, of course, one thing that I could do, I could use numbers in a smaller number range, but where the number in that bottom box would be a decimal as well.